Hello friends, in this video we are going to solve a GATE 2017 question which is on BFS for an undirected graph, and we are going to use a shortcut method which we discussed in our previous video. You can please find its link in the description box below. You can please go to that video, review your basics a bit, and then you can please start with this question. Also, I'm going to explain it in a very simple manner, so even if it can also be possible that you just see this video and it's just very clear to you. Okay, so now what is important in GATE is basically a competitive exam in which you need to basically answer maximum questions in the given time to you. So you should know a method in which you are performing questions quickly, you are answering questions quickly and also in a correct manner, because there is also negative marking over there, right? So in this video we are going to we are going to learn a technique wherein we solve our questions in that manner. Okay, so now we already know the basics. We already know that BFS, it processes nodes level by level. BFS is for breadth first search. Okay, so we process the nodes level by level. We process all the neighbors of a particular node first and then move on to the next nodes and their neighbors. And we use a queue data structure for that. Okay, that's all revised. We've all done that, practiced it. But now, how to answer a GATE question in which the examiner actually wants us to answer. Now, when I say the examiner wants us to answer, what I mean is that you all know that breadth first traversal, breadth first search answers could vary, right? BFS orders, for a particular graph, there can be multiple BFS orders, but our options are limited. So we actually need to answer the question in which we get a favorable answer in the options there. So sometimes you need to solve a question by checking on the options. It's not that you'll get directly the answer over there, no, but you need to solve your question in the direction that you find your answer in the options, right? So we are going to use that approach over here. So it's very easy. Once you just learn that and practice that, you'll get acquainted with it in very less amount of time. Okay, so let's start now. Uh, Now, a very important thing that you'll see over here when you analyze this graph is none of the nodes is marked as the starting point. That means the examiner wants us to check with any of the nodes. That means any of these nodes could be a starting point to perform the breadth first search algorithm over here. Okay. Next important thing is that we have been given multiple options for the answers over here. So we need to proceed in that direction. So what is my approach? I start with the first vertex over here, which is M. Okay. Because I've been given four options, I'll start with first node in all these four options one by one. Okay, so I'll start with M first, then N first, then Q first, and then P first. Okay, so in my first attempt, that is, I'm going to take four attempts, and in each of the attempts I'm going to take my starting node as M, N, Q and P over here. Okay, so I am not talking about one BFS traversal over here, I am talking about four BFS traversals. Okay, so I start with my first starting node over here as M. Okay, so I'm just going to remove this for a bit of space and clarity. Okay, yeah. Okay, so now when I start with M, I mark it as visited. Now the immediate neighbors over here are what? They are N, Q, R. Okay, let's just mark the nodes. That means in the next run, I might be processing N, I might be taking, I might be processing N, or I might be processing Q, or I might be processing R. Right, now I check the options. I have this first node M over here, then the second node N over here. Okay, that is fine. So if I'm taking my second node as n, if I'm taking this out, then the next element which I take out will be either q, or it has to be either r, because these can be varied. These can be in any order over here, right? These could be in any order, but I am not going to move to the next level over here. I am not going to move to the next level till the nodes of this level are processed. This is very clear, okay? So that means if you just check the option over here, which we have is, we have M, then we have N, then we have O. So that means this is incorrect. This is not possible, because we cannot move to the next level till the nodes in the previous level are processed, right? That is because of the logic that BFS follows. Okay, so that means A is not possible. Next, again, we'll start with N as the starting index, starting vertex then. Okay, so now we start with N as the starting vertex. Sorry. Let's just mark it unprocessed. Yeah. Now we start with N as my starting vertex. Okay. Now, similarly, when I process n, I'll be inserting its neighbors into the queue. That are which ones? We have q over here. Okay, I just see this option and I try to make this option as my answer. Okay, so we have q, then we have m. Okay, fine. Then we have p. But this is again not possible because only other child left is o. So it has to be, I need to process these elements first before moving to the next level. Again, using that same logic, I cannot move to P before O is processed. Right? I cannot move to P before O is processed because this is in the same level. Right? So this is in the same level. So that means this is also not possible. This option over here is also not possible. Then we'll move to our next option. Okay, we'll check next option for now. So next option has what? Next option has Q as the starting point. Now we'll check Q as the starting point. So when you starting with Q, we have its neighbors as M, N, O, and P. Let's see the option. The option is M, fine, N, and then R. But R is not connected directly to Q. Only way which we can reach R is through M. But I cannot process M before I process all the neighbors of Q. That means this option is also not possible. So I cross this also. That means only left option, favorable option is D. So this is the answer straight away, right? But we should also verify our answer whether this is also by processing it once, that whether this is the correct answer or not. So what we do is we start with P as the starting node now. So we start with P as the starting node. I mark all the edges as black again. Okay, so it's a bit clumsy right now. Just bear with me with this. Okay. Okay. I start with P as my starting node over here. And now the neighbors of P are Q and O. I can process them in any order, right? I can also write O and Q, that does not matter. So till here it is fine. P, O, Q. Okay, fine. Okay, so I mark them processed as well. Then I mark P, I mark O, I mark Q. Fine. This is so far so good. Let's choose green, let's say. Okay. Now, next element is n. So we'll see if we are able to reach n. Can we reach n? Yes, we can reach it by using n. Now, why I went through O's direction? Because I processed O first, right? So I need to go from that direction, but you can also go from Q side. Doesn't matter. Okay. So the next element after this is, now O had two children. O had two neighbors, Q and N, but Q was already processed. So O had only one unprocessed, unvisited node left, which was N, which is now visited. Okay, that means now we need to move towards Q's children, which is only M over here left, right? So we mark M visited, and we visit it through this path Q to M, and it is over here also in the same manner in which we require it to be. After N, the next element which is coming is M. Okay, so now finally we process M, and when we process M, there is only one child which is R. So next node is R over here, right? And we mark it as visited, and we finally get to our answer, which is this. This is the correct answer, and we have solved this question using the shortcut method. And now, what if we would have chosen the basic queues method, right? Or we would have started checking all the possible BFS traversal orders which we could make out from this question. It would have really taken you a lot amount of time, right? So please consider practicing this method. It really helps. It really helped me during my GATE exam, and it really helps you to solve your question in the smallest amount of time, in shortest span of time, and reaching your answer quickly and attempting more questions, which would really help you to improve your GATE score or to get a good GATE rank. So thank you all. If you like this video, please like it, subscribe to my channel, and keep the bell icon pressed for more updates, for newer videos which I'll be making continuously since GATE exam is approaching. All the very best to you. Keep practicing, keep learning. Thank you.